Hello and welcome everyone to the next session of our Day 1 and Beyond webinar series. Our topic today is disaster recovery in OCI, where we'll cover the key concepts, techniques, and best practices for designing a highly available disaster recovery solution in Oracle Cloud. You will also learn about disaster recovery features and things like Oracle Cloud Guard, backup and restore, cloning, replicas, cross-region backups, and integration with other platforms. My name is Renu Bhatt, Program Lead for the Customer Enablement team here at Oracle. And we are so lucky to have one of our most popular presenters here today. We have Jason Cook. We also have Olivia and Hannah Raksha, who will be joining us in presenting and giving the demonstrations. And now I'll hand it over to Jason. Have a great learning experience, everyone.
Wow, with that kind of introduction, Renu, thank you. You set a high bar for me today, so I'll have to see what I can do to rise to that challenge. I've got a great group with me today. I'm going to start off, and then I'm going to pass it on to a few of the people. We're going to do some demos. We're going to talk about some of our technologies. But what I want you guys to get out of this session is basically three things. How you can start up a DR project. Like, what are some of those first steps to get going? Things like engaging the business, some of the key requirements you need to gather, the fun stuff of building the architecture and the solution to enable a good DR and HA. We'll get into a kind of overview of one of my favorite services that's going to help automate some of those recovery objectives. And then we're going to get a little bit of a demo of how things work with the Oracle database of doing a failover with DataGuard. Okay. So let's talk about getting, what are the first steps? Getting started, right? Oftentimes with disaster recovery, we in an IT program, we don't need to convince ourselves why it's important. We know DR is important. We know HA is important. Oftentimes the challenge is, how do I get the business going? Right? How do I engage the business to make sure we've got support, to enable us to continue with the DR projects, not just for the initial setup, but for the long term with testing and including additional apps to include the whole portfolio of things that are important to our business. And as we talk about this, it's a conversation you start with the business. You talk about things with the business about lost revenue. Think about your e-commerce site or that application that directly works with your customers. And you talk with the business of what's the cost of e-com going down. And normally they'll know that within, the cost within hours, oftentimes cost within minutes. We talked about lost productivity, right? We've got dashboards, we've got internal applications we use to collaborate with each other, right? What happens when those applications are down and I can't, say, develop code, or I can't do internal warehousing or manufacturing? I've got people standing idle. There's lost brand and trust, right? Recently here, we've all seen the impact of when, bad updates by IT are sent out and, people get stuck at airports. People can't shop on their favorite website. People can't check in to their hotel because the IT system's being down. Those customers oftentimes are going to look at maybe a different provider for the services they're looking for. So these are some of the conversations we want to talk about to, talk with the business about what's the impact when we have a DR event. And some of this is a little bit of a, you're kind of scaring them to a certain degree. It's the same reason we get car insurance, right? When a bad thing happens, right, what's the outcome? And for small, medium-sized businesses, when they experience some sort of major DR event, a lot of them fail to open. A lot of them, even if they're able to open, will hobble by for a few weeks or months and will still ultimately end up failing. Larger enterprises typically have resources to ride it out, but medium to small-sized businesses, when a big DR event happens, whether it's natural disaster or something else, may have an impact that ultimately dooms their business long term, okay? And disasters, as we talk about them, come in a couple different shapes and sizes. Let me flip here. They come into things like operational failures or natural disasters, right? Ops failures are some things we see all the time. The network is down. We've had some sort of issues in the data center, cooling and heating. We often talk about natural disasters, right? Those are those big events, obviously earthquakes, tsunami, anything that would impact an entire region. And there's always human-caused events, right? Events where someone accidentally deployed, well, a bad update is a good example of one, or they deleted part of the environment, they deleted the data that runs our environment. These are the kind of things as you're talking with the business that you want to make sure you plan for, right? Business, what happens if e-com's down for a couple hours because of a networking issue? Or what happens if someone deletes some of our critical data? How do we recover it, right? These types of discussions with the business are going to help us build the justification of why you need to do DR, and oftentimes give you the resources, which is the people, the funding, sometimes more importantly, the prioritization to be able to drive this. But it always starts back with a discussion with the business first. Trying to do DR and HA as an IT-only push is very hard to do. It's very much like pushing the rope uphill. Getting the business to see the value of it and the risk, like the scary part of the conversation, will oftentimes give you the prioritization and funding to make sure that you can start it and it's a collaboration between you and the business to meet their outcomes. If you've ever had one of these discussions with the business, oftentimes they'll come back and say, well, we want to never be down and we don't want to lose any data. Oftentimes in DR, we talk about RPO and RTO. And these are old terms from the 70s, but if you haven't heard them before, RPO is your recovery point objective. Think about that as just your tolerance for data loss, right? Bad event happens, and how much data can you lose? We also talk about RTO, recovery time objective. If you don't know what that is or haven't come into it, that's how long can you be down, your tolerance for downtime. And if you talk to the business, oftentimes the first response is going to be, I want 0 and 0. I want to lose no data, and I don't want to be down for any length of time whatsoever. And that's definitely achievable. And for some applications, again, I'll pick on like an e-commerce. Those are places you probably do want to try to achieve a very low RTO and RPO. But there's an affordability challenge that oftentimes also comes into play when we talk about requirements. And affordability goes like this, right? For any of the solutions we put together, there's going to be a cost for your DR environment. Now, if we want to do something like an active-active, right, you're going to have your production environment, you're going to have a DR or HA-like environment, and it's going to be the exact clone. So if your production costs you $1,000 a day, your DR will cost you $1,000 a day. But when you get into these active-active scenarios where you need to have 0 downtime, 0 data loss, you also have to pay for tools to do the data replication. You've got to pay for tools for observability. You've got people to do testing. And oftentimes the cost is not just double. It can sometimes be triple or quadruple your existing production cost. So if your prod costs you $1,000 a day, for your run rate, doing a full-on active to get that 0 and 0 RT and RPO can be $3,000, $4,000 a day. So affordability is very important as we talk with the business to make sure they understand that as we get down to 0, the cost is higher. But the nice part is oftentimes once we've had that conversation, it's going to be expensive. We've got some other options, right? There's not just active when it comes to DR. We look at scenarios like active-passive, right? Where I still got a really strong RTO, right? I'm not going to lose almost any data or downtime. I'm going to be up within a few minutes. You're going to keep all your data. We can go to pilot light, which is, from what I've seen, one of the most popular approaches of the DR. And the idea of the pilot light is you're trying to have almost next to no data loss, a very short RTO, probably minutes, maybe hours, depending on how many apps you have. But you're trying to cost optimize your DR solution. You can't break the bank. You understand the importance of it, but you want to make sure you have enough DR that you're not down for days. So we get into a lot of pilot-like scenarios with many of our customers to try to optimize DR outcomes with cost outcomes. And it's still perfectly okay for apps that don't run your business, legacy apps, dashboard apps, to do backups and restores, right? Some things can be down for days and can be recovered at a later time if you experience some sort of significant data loss or outage. Okay, these are normally the 4 outcomes we talk about, and they all have different cost profiles. They have all different RT and RPO targets. Generally, as you're talking with the business, you want to make sure you understand what the pain is when they're down, oftentimes expressed in dollars, productivity, brand. You want to understand the kind of approaches that they want to try to achieve, right? Do I want to be up all the time, or is it okay that I can have a smaller window of time to bring things back up and cost optimize what it costs for DR? And once you've got the requirements, once you've got the approaches, then we get to the fun part as architects, right? This is the part we actually can take all these and turn them into a solution. Okay. One of the things I'm just going to put, what is the future DR? DR has been around a long time. Concepts like RTO and RPO been around since the 70s. But one of the things in the areas I cover, and I cover a lot of retail type customers, is the concept of variable recovery times. Now, we're all probably familiar with the cloud and the marketing around. You can scale up and you can scale down. Your production can meet the needs of your business if it's like Black Friday or if you have a sudden spike, and you can scale up your production environment. But what I'm hearing here in a lot of DR discussions here in the past year or so is the same concept apply for DR? Can I scale up my DR capacity and by extension, make my RT and RPO smaller when it matters most? And for some industries like retail, when it matters most is around the holidays. That's where they make a lot of their sales. And so this is something we're starting to work with customers on, is this idea of, yes, scale up and down your production for your demand, but also look at how we can potentially scale up your infrastructure running your DR and give you a better RT and RPO when it counts. And when it doesn't through their parts of the year, scale it back down, maybe take a little more time, but at the same time, reduce your costs. So Something you'll probably see in future customer connect sessions. We do DR all the time. This is one you're going to probably see within a few more months. We have more detail on what the heck this is and where's it going as an industry. But let's get in the fun part. Let's talk about some solution design, some architecture, like what goes behind meeting some of these approaches we talked about in DR. And we're going to use an example here as the backdrop for all the architecture and foundational things we're going to talk about. We're going to talk about Pilot Light. Again, this is one of the more popular approaches with customers. The idea I'm going to have good DR, I'm going to cost optimize. The example we're going to use here is some sort of warehousing logistic app. The app is in Azure. The database is in Oracle, right? This follows our multi-cloud strategy. We're going to try to get an RTO of less than an hour, an RPO of next to 0 because we don't want to lose any data loss. We're going to try to cost optimize. Okay, with that as the backdrop, let's talk about architecture and some of the design principles. First one, as many of you know, Oracle's got data centers all across the world. For this scenario, we're going to talk about the classic pairing of Ashburn and Phoenix, and I'll explain why. Those two are pretty popular. In all those worldwide regions, you have the concept of fault domains and availability domains. Okay, regions are things like Phoenix and Ashburn. Those are regions. But in each one of those regions, we have availability domains. Or more simply put, these are just data centers. You could drive up to the building, you could walk in there, well, if you had access, and you can see rows and rows of equipment that make up the network, the storage, the compute. And they're basically a physically independent data center. So in the Ashburn region, we have 3 availability domains, or simply put, we've got 3 data centers. In Phoenix, same thing. We've got 3 availability domains, 3 data centers, right? Within each one of those availability domains, we've got a concept called fault domains. Now, fault domains are a separate room inside each one of those availability domains that host independent racks of server storage network. They have their own cooling and powering for that room. And so kind of think of them as a mini data center inside each AD. So if there's some sort of infrastructure impact within one fault domain, it doesn't impact the other 2 fault domains in each AD. Okay, where do these come into play? Oftentimes when you're talking about high availability solutions, right? High availability, you're trying to have the business outcome of maximizing your uptime and never want to be down. And it's expressed in terms like 99.9, 99.99, 99.9995, right? That is an HA outcome and an HA target. Oftentimes, you're going to look at hosting your workloads across multiple fault domains and oftentimes multiple availability domains to meet an HA target. For DR, you can do DR across the availability domains. For small localized DR events, right? Maybe I'm just worried about an entire building being impacted. But most of my customers look at DR from a cross-region standpoint, right? They are worried about a major hardware event, but they're also worried about a major, geo event like an earthquake or something else that is more, a natural disaster. Okay, so DR is oftentimes spread across multiple regions. So in the example that we had a Pilot Light example, right? The customer wants HA, so of course they spread their workload out across multiple fault domains there on the right and multiple availability domains. That's their HA solution. For DR, they're going to spread their workload across 2 regions. And because with a Pilot Light, you're trying to cost optimize, they're going to have a little bitty footprint in Phoenix. Smallest footprint they can have to achieve data replication, core configuration, all their binaries, all their core data is over there that they can recover all their environments they need. All the data is there. They may need to take some time to scale up because, again, it's Pilot Light, but they've got a footprint in another region. Okay. That's how you'd use regions, availability domains, and fault domains to meet both HA and DR outcomes. Let's keep going. Let's talk about what's the next layer of the foundation. It's networking. So we're going to talk about the outside and the inside. On the outside, you need to consider what kind of connectivity do I have from my on-premise environments, from my offices to OCI. And probably today, most customers, if you've already in OCI, you're probably using something like a Fast Connect or multiple Fast Connect connections to provide that dedicated high bandwidth throughput so you can get to production on the right there in Ashburn. For DR region, you get options, right? If we're doing Pilot Light, you might consider just starting with a VPN, right? I'm kind of cost optimize what I'm doing here. You could do Fast Connect as well. It's perfectly fine. But you've got some options of what you want to do with DR depending on what you think your needs are of your on-premise environment. As we were on the outside, because this is a multi-cloud scenario, right? We talked about the apps running in Azure, the databases being an OCI. You want to think about things like an interconnect, which is our solution to be able to take the 2 clouds, put them together with a fast, low latency connection. If you have that today in production, you'll need another interconnect from your Phoenix site, your DR site, to get to Azure as well. so that during an event, you can continue connecting from your database to your apps. And if this application has some sort of front presence, think e-commerce or a website or something else, you probably need to look at how your customers are going to connect. And that gets into things like DNS traffic management, potentially load balancers, a WAF or an external WAF, a CDN if you're using that externally. You need to think about that layer also of how my customers are going to connect and make sure that it is available and set up ahead of time in your DR environment. Okay. The inside connection is much simpler. Of course, between your production site and your DR site, you need to have network connectivity with things like DataGuard, right? DataGuard will be that technology we talk about and demo later today of how data from production is going to get to your database over in Phoenix, okay? And DataGuard requires that you have something like a remote peering connection to connect the two sites. For some of the replication technologies, like if you're using object storage or block volume, you'll be able to use the Oracle backbone to be able to transfer that data across, and you won't need a remote peering connection. But for most DR solutions, you're going to have some sort of database. It's going to need some sort of RPC connection to be able to go from production to DR. Okay. And we talked about data replication a little bit, right? If you're an OCI, more than likely you came because you've got Oracle databases. We've got multiple solutions to stand that up, whether you're using base database systems, you're using XSCS, using the newer autonomous service, and we've got multiple solutions to be able to migrate data from production to DR. It's going to kind of depend on your RPO, RTO requirements. Things like Golden Gate is probably like the Cadillac service of replicating data over, right? With making sure that you have the maximum RPO, right? The lowest data loss possible. But a lot of customers use DataGuard or Active Data as well. And there's other solutions as well to migrate data over from the Oracle database. If you've got applications with us, right, and the data is important, maybe you've got an app that stores state, or you've got other data that needs to be recovered in an event, you could be looking at something like block volume replication. If you've got shared storage, you might be looking at something like file storage. And if you've built something that's more cloud native, maybe using functions and Kubernetes service, you're probably using something like object storage. All three of these have different replication technologies that are just configuration events, right? You configure it to replicate from production to a location inside your DR environment. All those replications go on the Oracle backbone. Okay, but this is just another layer as we talk about the backbone, the foundation that you need to build out to enable your DR site. So if we put it all together, right, for our pilot light scenario, it could look something like this, right? Classic 3-tier, application where we've got a front-end load balancer, probably some DNS traffic management on top of that, or a CDN or a WAF. We've got our application servers deployed out, potentially a small footprint in your DR site, that is a replication of your full production environment. You've got your, in this case, a base database system, I believe, doing DataGuard replication to a small node that's just big enough to receive replication. And when a DR event happens, you might scale out the number of application servers you have. You more than likely scale up your base database system. You do a database failover, which we'll see a little bit of a demo today. And there might be some DNS magic you do on the front end to make sure that your users can connect to the environment inside of your DR site. And this is kind of how you put the whole foundation together of meeting customer RTO and RPO demands with whatever the approach we pick, and then how we go through each layer of your foundation to make sure you got a DR site that can bring your applications back up. Okay. Now I'm going to hand it over to Olivia, and she's going to talk about one of the services that helps put it all together. It's a tool called Full Stack Disaster Recovery. I'll let her do the deep dive on this, but the takeaway from this is this tool is going to help automate a lot of the tasks you do when a DR event happens.
Full Stack Disaster Recovery, or FSDR. So to kind of set the stage, we have a customer quote here. So when a disaster happens, I do not have enough people to recover all the critical environments we support today. And so Jason, do you have an example of maybe when there were not enough people and kind of how FSDR helped with that?
Yeah, absolutely. Every IT team faces the challenge of not having enough people. You don't have enough people oftentimes to take care of your production demands, let alone if there was a major event today, it's not one environment, it's 15 environments, it's 30 environments you have to recover. And so one of the customers I was working with about a year ago had an environment that looks very much like that one slide we had. It was a warehousing application. It had classic 3-tier type approach, database, apps, load balancers. But they had 12 of them, right? They had 12 of these environments. And the concern they had is, yes, we could recover one of these. We could do it manually. We could probably do it in about an hour. We've got a good playbook. We're not worried about that. But the concern we have is if we lost all 12 and they're in the same spot, we don't have enough people to be able to get 12 environments back. And so with FSDR, what we did, and Olivia, I know you're going to get into some of the details of it, so I don't want to steal your thunder, but with FSDR, what we basically did was automate their playbook, add some additional things in there we can talk about here in a second, and get to the point where we could prove that one environment could be automatically recovered, push button recovery within about 20 minutes. And to do the other 11 environments wouldn't have added much more on, to the point where we could have done all 12 simultaneously and got everything back within that 20-minute time frame. 12 environments, not just one. And that's where some of the power of having some automation like this tool come into play was, I can do one, but what happens if I got to do many? You got to have automation. And that's something we proved out with a customer that they could definitely have as a business outcome.
And so building off of what Jason said and kind of what FSDR is and some of those key features, so it's going to come into play to help you achieve business continuity quickly. So whether operations needs to move to an entirely different region while performing major planned maintenance, or if an organization needs to recover from any number of catastrophic events. So FSDR would orchestrate the transition of your different resources, so compute, database applications between OCI regions from all over with a single click. So you can also automate the necessary steps to recover your business systems without having to redesign or re-architect your existing infrastructure. And so one aspect of this is push button recovery. So you can execute and monitor recoveries without needing to understand anything about the complex processes each business system requires. So you can observe each and every step of a recovery operation through the OCI console, so you can pause, resume, or cancel a recovery operation at any point in that process. You can also reuse existing automations, so you don't need to discard any existing scripted automation. You can quickly create DR protection groups and DR or disaster recovery plans and deploy resources using REST APIs, CLI, SDK, Terraform, and Resource Manager. And Resource Manager is actually one of my favorite tools in OCI, so it's more of Terraform as a service. So you can automate the process of provisioning your infrastructure with the Resource Manager and also manage the state of that. That's one way to go about that automation. You can also auto-configure recovery steps. So you can configure the failover of common OCI services like compute or database without any code needed. All steps are fully automated and no human intervention is needed to transition compute, databases, and applications to a standby region. And then lastly, you can validate DR or disaster recovery before it's needed. So FSDR performs comprehensive pre-checks before a DR plan is executed to ensure the recovery operation will succeed in that standby region. So here's just a high-level failover scenario. So where the left-hand side is the primary region, which has gone down and we cannot access anything. So in this case, we're going to initiate the data guard failover for you. And then we're going to activate the volume groups in the standby region, which has all of the replicated boot and block volume servers from the newly activated block volumes. And then we'll launch those replicated servers. And after that, run any scripts that you have to start up your application at the end of your plan, so you can run those custom scripts. And most importantly, just want to note, we did all of this with the click of a button. You don't need to hand it off to application or database people. It's just a single click. So just want to switch gears and talk a little bit more about improving uptime with high availability. So to get started, availability is just the degree to which an application and database service is available. So your users can maybe experience frustration when their data is not available or the computing system is not performing as expected. And if you cannot access the application or database service, it is said to be unavailable. and the term downtime is used to refer to periods when a system is unavailable. And you're going to want to have your systems to always be ready. So for that, you would need high availability. And a system that is highly available is designed to provide uninterrupted computing services during essential time periods, most hours of the day, most days of the week, throughout the year. And a few things that are key characteristics of a highly available solution are reliability. So you want reliable hardware as one component of a HA or highly available solution. You want reliable software, so including the database, web servers, and applications is just as critical to implementing a HA solution. So for example, maybe low-cost hardware combined with software such as Oracle RAC or real application clusters can be used to implement a very reliable system. And the resilience of an Oracle RAC database would allow processing to continue even though individual servers may fail. So reliability is pretty important here. Also, recoverability. So it's important to determine what types of failures may occur in your HA environment and how to recover from those failures quickly in order to meet your different business requirements. So for example, if a critical table is accidentally deleted from the database, what action should you take to recover it? Does your infrastructure or architecture provide the ability to recover in the time specified in an SLA or service level agreement? Another key feature is continuous operation. So providing continuous access to your data is crucial when little or no downtime is acceptable to perform maintenance activities. So things like CPUs to your hardware or moving a database table to another location should be transparent to the user in a HA architecture. And with that, I'm going to pass it over to Hannah to go over a database failover demonstration.
So we're going to go through the maximum availability, high availability architecture diagram that Olivia just showed. And in a physical demo, we're going to begin by provisioning our rack instances. So by going to Oracle-based database service, ensuring the correct compartment, we're going to create our DB system, which we will name something easy to remember like rack system. Pick our domain, as well as any shape you're interested in. For me, that's going to be Intel 2.2. For storage, rack requires the Oracle Grid infrastructure. We're going to set our nodes to 2. And then I've already generated SSH keys, so I'm going to go ahead and upload them here. Once uploaded, pick your license type. For me, my license is included, and then we're going to specify our network information, as well as a host name. For simplicity, I just made it rack. Leave your diagnostics as is, or if you're interested in other selections. And then again, we're going to name DB and create a password for our admin. Follow your company's policy for backups. For me, I'm just going to do object storage 7-day retention. Now we're just going to wait for this to go ahead and switch to available. So here you can see there's our database. Clicking further in to view more information, we have the general information, backup. You can see data guard is not labeled. At the bottom here, we can find our PDB as well as any work requests. But what I'm going to go ahead and do now is connect to both nodes. So I'm going to open 2 browser tabs here so we can connect with both nodes side by side. Now, while I'm doing this setup, What I'm going to demonstrate is Oracle's ClusterWare's fencing ability by forcing a configuration that will trigger the built-in fencing features of RAC. With Oracle ClusterWare, fencing is handled at the node level by evicting the failed node via reboot or rebootless restart. So going ahead and connecting. So once we're connected, I'm going to examine the network settings on each node. So here we can see that one of the network interfaces, ENS3, has multiple IP addresses. These are each virtual interfaces for the virtual IPs used by each node and scan listener. So let's see what happens if one of our virtual nodes goes down. What I'm going to do is change ENS4 to down, forcing it to fail. And then checking that configuration again, you can see that ENS4 still exists, but no longer has the status up or running. We go ahead and check in on node 2. Here you can see the increase in virtual interfaces for network interface 3. So we have 3, 1, 3, 5 originally on node 2. But now we have 1, 2, 3, 4, and 5. So where did these new air quotes come from? If we go back to our first node, we can discover that this is where the virtual interfaces came from. Here we see clustering hard at work. Additionally, if we check the status of the cluster from each node, we'll see that only node 2 is online. Now, what happens if I go ahead and restart node 1? So restarting it and checking its configurations again, you can start to see the respective virtual interfaces move back from node 2 to the original node. So again, we have 1 and 2 on node 1, and we have 1, 3, and 5 on node 2. So one last thing we'll do is we're going to check status, and there we can see both nodes are online. Now we're going to switch over and introduce Oracle ClusterWare's Fast Application Notification Callout capability. Fast Application Notification, or FAN, is a critical component towards solving the poor experience that comes with planned maintenance, unplanned outages, and load imbalances that make database instances unavailable or even just unresponsive. So connecting and running the fan watcher bash script, I'm going to go ahead and kill the second node's process to simulate an unplanned outage. So in no time there, we can see the fan callout detailing the issued event. The first notifications give details on this node being down, and eventually, once it's rebooted, it's going to give details on the failure and the status of the now up node. Now, this is fantastic between fault domains, but what if an availability domain or even a whole region goes down? So from the database details page in our OCI console, we have the ability to enable active data guard. So going to our database and then clicking data guard associations, we're going to enable data guard, pick a name, as well as a region. So the original region is Phoenix, so we're going to switch and put our peer system in Ashburn. Same shape, same license, virtual network on Ashburn servers, and then a host name. You can pick between active data guard and data guard, but I'm going to leave active data guard. and input a password, specifically the one we did for admin. So we can see it's in the process of provisioning this peer system. So we're going to switch regions on the right to Ashburn. And we can see the system's already been created for us. Here we have the general information on the system, very much so like our original system, as well as the database and nodes. Once available, first thing we're going to do is simulate a switchover. So a switchover is a role reversal between the primary database and one of its standby databases. A switchover guarantees no data loss and is typically done for planned maintenance of the primary system. So there on the right, we're confirming that we are in one region, Ashburn, and on the left there, Phoenix. So before we do the switchover, we want to make sure that our primary and our physical standby are correct. So connecting to the databases. Here we can verify that we have Phoenix as our primary role and Ashburn as our physical standby. So switching back to the console, if you're doing a switchover manually, you'll always do it from the primary database. And it's as easy as clicking the three dots, clicking switchover, and typing in the database password. So once available, we're going to go back to our Cloud Shells, rerunning our select statement. You can see now we have Ashburn as a primary and Phoenix as our physical standby. Now, what about a failover? So a failover is a role transition in which one of the standby databases is transitioned to the primary role after the primary has either failed or become unreachable. A failover is started from the standby database that will become the primary. So because we just switched them, we're going to go back to our Phoenix. And again, as easy as we saw, three dots, failover, password. From there, it's going to go ahead and update. Once available, running our select script again, we can see we have Phoenix back in the primary role, as well as Ashburn in the physical standby. So now let me go ahead and show you more features of Active Data Guard, very specifically DML redirection. In order to do so, I'm going to create an ADG user and grant it specific roles. And then I just want to ensure that I've created this user. In order to do DML redirection, you have to alter both systems to set this as true. So there you can see I didn't create the user on the right side there, but when I do the select statement, the user exists. Now setting the redirect to true and then connecting to the database using the user we just created, I'm going to create a table and then connecting on the Ashburn side. What I'm going to do is describe this table. So again, I did not create table in Ashburn, but there we can see the table as described as I created it in Phoenix. Now, one final thing I'm going to do is insert a value into the table. And of course, make sure to commit. Once the commit is complete, we're going to go over to Ashburn. So verifying Phoenix has it. And there it is on Ashburn's side. So thank you all so much for joining us for today's session.
We've got some other recommended learning here. Some of these are live labs that you can do on FSDR. Some of these are just some of the announcements we've had around some of the technologies we're talking about. But if you'd like to learn more, of course, look at these and also pester your Oracle account team that supports your customers. We've got a wealth of smart people we can bring in to do demos, overviews, deep dives, and anything we talked about today.
And then we also have another slide for some other learnings, just to kind of expand on that. And you should be able to access these links within the next day or so. Right. And just one more thing, our next session will be navigating business success with predictive analytics on September 3rd at 10 a.m. Pacific. So we will cover the analytics services and tools available for you to use in Oracle Cloud. So we hope to see you all then.